Welcome to the second in the series of videos from the polymer group of the AMCASH project. In this video, you'll find out more about the mechanical testing capabilities we have to offer and how we can use them to help your company. So what is it and what does it do? Mechanical testing exerts forces on samples to help us find out the mechanical properties of different materials. How strong is it? How much can you stretch it before it deforms? How flexible is it? How much does it bend before it breaks? How brittle or elastic is it? How much does it compress before it fractures? In some cases, where the geometries allow, we can even test finished products. How can this information benefit you and your company? We can use mechanical testing to help determine the operational limits of your material or product, for example, the maximum compressive load. We can look at batch consistency. We can compare different materials to find out which is better suited to an application. We can determine the effect of using different processing conditions or of different additives. For example, polymers which have been cooled at different rates may have different mechanical properties as a result and could be weaker, stiffer, and more or less brittle than expected. We can measure the adhesion strength of a coating to see if the coating is going to pull off too easily or if it is bonded well enough for its application. Measuring mechanical properties can be extremely useful during the development of new products and can encompass any of the above. It can be used to test polymers, ceramics, composites, and fibres. So how does it work? The mechanical tester has a crosshead which moves up and down, exerting forces on the samples as it pushes or pulls on them. During a testing run, the changes in load and the displacement distance of the crosshead are measured. The analysis of the data gathered during the test run allows us to calculate various mechanical properties. There are several test setups that are possible, including tensile, compression, three-point bend, friction, and pull-off tests. For tensile, friction, and pull-off tests, the crosshead moves away from a stationary grip or platform. In a tensile test, the sample is clamped and pulled apart, and we can calculate the tensile strength and stiffness, Young's modulus, elastic limit, yield strength, elongation to break, and fracture behaviour of a sample. In a friction test, a weight is pulled across a surface. Different materials can be fixed to the weight and the surface to determine the slip behaviour and the static and kinetic coefficients of friction. For a pull-off test, a T-shaped dolly is first fixed to the surface of a coating. This is then pulled upwards until the coating debonds from the substrate, testing the adhesion or coating strength. For the compression and three-point bend tests, the crosshead moves towards the stationary platform. In a compression test, the sample is compressed under a pillar or plate, and we can find out properties such as the compressive strength, elastic limit, proportional limit, yield point, and yield strength. For a three-point bend test, the sample is supported at either end, while a loading pin presses down in the centre. From this we can determine the modulus of elasticity and bending, flexural stress, flexural strain, and fracture toughness. We have two mechanical testers, an Instron 5566 and an Instron 5507, with 4 different load cell options, meaning we can match a sample to the correct load cell for the amount of force required, giving the best possible sensitivity and highest quality data. Thank you for listening. If you'd like to get in touch or would like more information, please go to www.amcash.co.uk.